Good morning, students. Let's continue the the chapter thermal properties of matter. So far, we have seen the thermal expansion. The thermal expansion is of three types. One is linear expansion, the second one is areal expansion, and the third one is volume expansion. What is linear expansion? The expansion in length due to thermal energy is called as linear expansion. Now let us see today the areal expansion. Areal expansion. This areal expansion is also known as superficial expansion. This areal expansion is also known as superficial expansion. Now let's see which expansion is said to be areal expansion. The expansion in area. The expansion in area due to thermal energy is called areal expansion or it is also called the superficial expansion. Now let us consider we are having a plate. Suppose this is our plate whose area is A, and now the thermal energy is provided to it so that its area is get increased. The increase in area is shown by these dotted lines. These are the dotted lines. So this much is the increase in area del A. What is original area? A is the original area. The fractional change del A by A in area A. This del A by A is the fractional change in area A. This fractional change in area A is directly proportional to change in temperature. If the temperature is increased, then the fractional change in area is also get increased. This del A by A is equal to beta del T, where this beta is known as the coefficient of areal expansion, or it is also known as the coefficient of superficial expansion. What is this beta? Beta is the coefficient of areal expansion. Rearranging the terms in this equation 1, suppose this is equation 1, and if we rearrange the terms, what we get? Beta is equal to del A upon A divided by del T, and this is equal to del A upon A into del T. What is this del A? That is the change in area at T degree Celsius, and the original area. Suppose A0 be the original area, and suppose the temperature is increased from T0 to T, where this T0 is the initial temperature, T is the final temperature. Now let us consider that the initial temperature T0 is 0 degree Celsius. This T0 is the initial temperature and the final temperature is T and this T is 1 degree Celsius. So the increase in temperature del T is 1 degree Celsius. Now let us consider again that the area at 0 degree Celsius A0 is 1 meter cube. Okay, it is unity. What we consider here? That the increase in temperature is 1 degree Celsius and the original area is 1 meter cube. Then this coefficient of areal expansion is defined as this beta is, what is this beta? This is the ratio of change in area to the original area to the increase in temperature. So now let us see from this data that we say that the increase in temperature is unity, the area is unity, then the coefficient of areal expansion, what is its second name? That is also known as the superficial expansion. The coefficient of areal expansion of a solid is defined as what is it? This is the increase in area, is defined as increase in area per unit original area at 0 degree Celsius for 1 degree rise in temperature, for 1 degree rise in temperature. So this beta, if we substitute these values, this T naught, this change in temperature, this del T, then this beta is equal to what? This beta is equal to AT minus A naught numerically. Okay, this beta is equal to AT minus A naught numerically. So this is the coefficient of areal expansion. And now let us see the volume expansion of a solid. Volume expansion. This volume expansion is also known as cubical expansion. Its second name is cubical expansion. It is known as the volume expansion or it is the cubical expansion. Its definition is the expansion in volume due to thermal energy is called as volume expansion. The expansion in what? In volume. The expansion in volume due to thermal energy. The expansion in volume due to thermal energy is called volume expansion. Is called volume expansion. This is the volume expansion. Now let us consider we are having a cube. We are having a cube. So this is our cube. Okay, this is our cube and its volume is V. Its initial volume is V. And now thermal energy is provided to it. Then it get expand. Now the new cube is shown by these dotted lines. This is the new cube which is shown by the dotted lines. Or get it? This cube is expand in all direction. This cube is expand in all direction. This should be our new cube. So this is the change in volume del V. What is the original volume? The original volume is V and del V is the change in volume. The fractional change in volume del V upon V is directly proportional to del T. Del V is the change in volume and V is the original volume. This del V, change in volume divided by V is nothing but the fractional change in volume V, and this fractional change in volume V is directly proportional to the change in temperature. This del V by V is equal to gamma times del T, where this gamma is known as coefficient of volume expansion or cubical expansion. Coefficient of volume expansion or cubical expansion. Now this is our equation number 3, and rearranging the term, what we get? We get gamma is equal to del this gamma is equal to this gamma is equal to del V by V divided by del T. This is gamma, and this gamma is equal to let's rewrite me it again, del V divided by V divided by del T. Are you get it? What is this del V? Del V is the change in volume. Suppose Vt be the volume at T degree Celsius and the initial value is V0. Then Vt minus V0 divided by V0 T minus T0, where T is the final temperature, T0 is the initial temperature. Now let us consider in this equation that we are having a cube whose volume at initial temperature is V0 and is 1 meter cube. What is initial volume? The initial volume is 1 meter cube. The initial volume is 1 meter cube. And now let us consider that the change in temperature, this del T means the T minus T0 is 1 degree Celsius. Okay, the initial temperature is 0 degree Celsius and the final temperature is T. The final temperature means the temperature is raised by 1 degree Celsius, then T minus T0 is 1 degree Celsius. Now substitute this in this equation, we get the coefficient the coefficient of volume expansion. Its second name is cubical expansion. The coefficient of volume expansion of a solid is defined as increase in volume. Which is increase in volume? This Vt minus V1. This is the increase in volume per increase in volume per unit original volume at 0 degree Celsius for 1 degree rise in temperature. 1 degree rise in temperature. Here this Vt is the final value and V0 is the volume at 0 degree Celsius. Instead of knowing the volumes of a body at 0 degree Celsius, if one know the volume at T1 degree Celsius and the volume at T2 degree Celsius are V2 minus V1, then V2 is the final volume and V1 is the initial volume. Then the equation is rearranged as gamma is equal to V2 minus V1 divided by V1. This V2 is what? This V2 is Vt and V1 is V0, that is the initial volume. This V2 is volume at T2 degree Celsius. This V1 is volume at volume at T1 degree Celsius. This T2 is the final temperature. This T2 is the final temperature and this T1 is the initial temperature. So this volume V2 is nothing but the final volume. This is also the final volume. And what about this V1? This is the initial volume. If one knows the volumes at T1 and T2 degree Celsius, then also the coefficient of volume expansion is calculated by knowing this formula. The solids, they are having the definite shape. So when the solids are heated, then one can directly calculate its change in volume. But for fluids, the fluids, they are not having the regular shape. They are having the shape of the container in which they are enclosed. What are the fluids? Fluids are the liquid and gases. So when we consider about the expansion of fluid, we have to consider the expansion of container also. This is all about the areal expansion and volume expansion. Thank you.